So you're going to be given some data tables. This first particular one is giving us what? The percentage of U.S. households with TVs with cable television. Great. Okay. So do you remember scatter plots, best fit lines, all that sort of thing? You really have only done best fit lines, I think. You'll have to tell me when we're done with this exercise if you did any of this last year. But here's real data. In 1980, 22.6% of the population had TVs with cable and so on. And then this just turned it into a scatter plot. So we essentially have to change these into points so that we can enter them into our calculator to create a scatter plot. Are you with me? Okay. So let's do years since 1980. Sound good to you? So the first point would be 0, 22.6, and that's really what they just plotted over here. Then 5 and 46.2. Do we get the point? Then 10 and 59, and I'm not going to go through all of these. I'm going to jump to the calculator, and you are too. Do you remember what you have to hit to enter data? Stat. Good. It's below your delete button. Stat. And then edit will allow you to edit lists. Now, if there's anything in there, which I do have, you scroll up to the list, highlight it, hit clear. It'll clear all out of the bottom. Then when you scroll back down, it will voila be gone. So my x coordinates are 0, 5, 10, 15, and what x coordinate would 2002 be? Oh, yeah. And then my list 2, the y-coordinate with 0 is 22.6, and then 46.2, 59, 65.7, and 68.9. Now, you have to turn on your scatter plot. So above y equals, it says stat plot, so you'd hit second y equals. And yours probably are all off, yes? Mine is on because I already did this today, but turn it on, go in, select on. Now, you can choose from, scatter plot should already by default be selected, so we're going to stick with that one. But there's a line graph that would then connect all my points with a line. There's a histogram. There's a box and whisker. And there's, what does that look like to you? Step function. I've never used that. I'm trying to think what context that would be used in. But we're going to stick with scatter plot. You all are going to stick with scatter plot. I'm going to change mine to this connecting the points just for the sake of showing you something, but you guys all keep it on scatter plot. Now, go to your second y equals. Then, once you have that turned on, go to your window and look at your x coordinates. They were from 0 to 22, so I'm going to make mine 0 to 25 just to make sure I encompass all of that. And my y's went anywhere from 22.6 to 68.9. I'll go from 0 to 70. And then we can hit graph. Now, like I said, I did the line graph, so mine's connecting all of my 5 points. You don't have that. You just have a scatter plot. But the reason I connected them with a line was just for you to see what type of function parent graph does this look like. The general shape, does it look like a line, a parabola, a log, right? Makes sense, we're in the log chapter. But some of yours tonight won't be logs and won't be exponentials. You have to decide what you think it is. And then you have to run a regression, and your calculator will write the equation of that log graph. Okay, so here's how we do that. First of all, let me quickly go back and change mine just to a scatter plot. Okay, so you guys all look like that. So to run, and you guys probably did this before in Algebra 1 with a line, but if you hit stat again, once your scatter plot's there, hit stat, we want it to calculate for us. So scroll over to calc at the top. Now there's a boatload of regressions that you can choose from. If you think it looks like a line, you would run a linear regression. If you think the scatter plot looks like a quadratic, you run a quadratic regression. Cubic, quartic, another version of a linear, which is the same as the other one. ln, that's natural log. It actually doesn't do a plain old log regression. You have to use the natural log. So we will use that, but before we do, there's an exponential regression. Power regression you won't ever use. I don't know what that is. Sine regression. You know last year how you had the you plot different points and you had to write an equation for high tide, low tide type of questions? So I had a theory that they would never put one of those on the exam that was a sine regression, was a sine curve. I had a theory that they would always do a cosine because otherwise kids, if they knew this, they could use their calculator. And they didn't really want you to cheat like that. They wanted you to understand all the mechanics. So that was my theory. I always told my kids I bet it would be a cosine, but that's just a guess. Anyway, you're beyond that exam. You don't care anymore. So this is a log regression. You guys all said it looked like a log. We're going to use an ln regression. So when we click that, our x list, this should already be right. Our x coordinates, we typed into our list 1. Our y coordinates, we turned into list 2. We didn't have any frequency, so we're just going to go right down to calculate. And what happens? Error. Why do you think that happened? It says error domain. Well, think about domain. Domains are which values? Your x values, and we're trying to take the log of these, correct? What would be the trouble with the x values we have? Think. Where? Someone said something that was right, but they said it under their breath, and I don't know. Yeah? Right. It's because one of our x coordinates is 0, and you can't take the log of 0. So you wouldn't know this until you got to this point in time. We can't do this in years since 1980 because otherwise we wouldn't be able to include that point. So if we go back to our list, go to stat, edit our list, instead of going years since 1980, can we do years since 1979? So everything will be 1. And instead of 5, it'll be 6, 11, 16, and 23. Increase each of those by 1, and then rerun the regression. Stat, calculate, scroll down to ln regression, enter, and then scroll down to calculate, and we should all be good. Can someone else answer Matt's question? Because I don't want to make myself crazy. So you'll always get the structure of the formula at the top. Y equals a plus b ln of x. So we will do y equals, they'll tell you the a value, I'll round to the nearest tenth, 21.8, plus 15.2 is your b ln of x. Now, knowing what we know now, what's happening to the number of U.S. households with TVs with cable television? It's going down because, and we wouldn't have thought of it, but Netflix and all these other things are making people go away from cable. So really what we'll probably see happen is more of a quadratic kind of thing. But again, no model is perfect. For the time being, the log was the best idea. But obviously, time goes by and things come up that we didn't foresee, and so models are never 100% accurate. Okay? All right, number 6. You're going to get to something like this on your homework. And we're going to rewrite this model in terms of base E. So currently, it is in this format that you will remember from last year. Do you remember last year when you did, I don't know what variables Mrs. Zagai used, but you kind of did something like this? Remember that? So according to that model, what is the rate of growth here? 1.7%, okay? And that truly is the rate of growth of whatever this thing is, world population. They want us, though, to rewrite this model in terms of base E. So essentially, they want us to write it in this format, okay? Which means we have no idea what K is. We're going to figure that out. K, although it's closely tied to the rate, is not exactly the same as the rate. So how do we do that? And this is going to seem pretty confusing, but you'll see how it works. What you're going to do to change it to this E format is you're going to insert E to the natural log of that 1.017 to the x power. I'm replacing 1.017 with e to the ln of 1.017. Because think about that going backwards. Wouldn't your e to the ln cancel? Right? But what it allows us to do is, here's our initial value still, 2.557. Here's our e. This is your k. So if you type in the natural log of 1.017, it's 0.01685. So I'm going to say 0.0169 x, just to round. So you can see that K value is not exactly the rate, but it's pretty darn close, and it's usually pretty close. The only time it actually is the rate is the PERT formula when we're talking finance. If they tell you a rate of 3.2%, then you use that as your rate in the PERT formula. But in general exponential growth, it's not exactly the same, but it should always be very close. Does this make sense? Rachel, you look like your mind is blown. No? You good? All right. The only other one